Let's do a simple unit conversion example. Let's convert 70 miles per hour into kilometers per second. First thing we need to note is what our actual unit conversion factors are. So 1 mile equals right around 1.6 kilometers. We also know that 1 hour equals 60 minutes. And then finally, 1 minute equals 60 seconds. So these are our factors. Now all we need to do is set up a simple grid system. And what I mean by grid system is, well, you'll see right now. It's like a train track. So here's our 70 miles per hour. And let's create our grid or our track. We know that for every 1 mile, that equals 1.6 kilometers. And when we do this, miles are going to cancel and we're left with kilometers. But we're not done with our grid yet. We also note that for every 1 hour, that equals 60 minutes. And when we do this, hours cancel and we're left with minutes. But then finally, for every 1 minute, that equals 60 seconds. And when we do this, minutes cancel. So now the only units that we have left are kilometers and seconds. So 70 times 1.6 divided by 60 divided by 60, that equals 0.03 kilometers per second. So that's our unit conversion. Now we can convert this, by the way, to scientific notation. It's not a particularly small number, but it's good to practice scientific notation just to get used to it. So this converted into scientific notation would be, remember, 1, 2, or 3 times 10 to the negative 2 kilometers per second. So we start with the decimal point here. We go over 1, 2, which means this is 3 times 10 to the negative 2. And again, all this is saying is 3 times 1, 1, 2. Oops, can't see that too well here. Let's erase this. And let's do that again. This is just saying 3 times, here's our 1, here's our decimal, we go over 1, 2 right here. So it's 3 times 0.01, which equals 0.03 kilometers per second. But like I said, it's nice to get used to writing in scientific notation, because when you start dealing with really, really big numbers or really, really small numbers, having a bunch of zeros and or significant figures can get really cumbersome. So the use of scientific notation is really quite helpful. Okay, let's do another example of scientific notation. But in this example, let's convert 70 kilometers per second into miles per hour. Okay, once again, we need to know what our unit conversion factors are. So let's write those down. 1 mile equals about 1.6 kilometers. We also note that 1 hour equals 60 minutes. And then finally, 1 minute equals 60 seconds. And once again, we're going to set up our grid system or our tracks. So 70 kilometers per second. Here's our track. We know that for every 1.6 kilometers, that equals 1 mile. And again, when we do this, kilometers are going to cancel and we're left with miles. We're not done yet though. So now we need to convert out our seconds into hours. So for every 60 seconds, that equals 1 minute. And again, when we do this, seconds cancel. And then we also note that every 60 minutes equals 1 hour. And again, when we do this, minutes cancel. So now the only units that we have left are miles and hours. So 70 times 1 times 60 times 60 divided by 1.6. And when you do this math, you're going to get 156,586 miles per hour. That's a lot. Now, this might not look like it makes sense, but it actually does. 70 kilometers per second means that every second of time you travel, you have gone 70 kilometers. That's a lot. If you were to convert those 70 kilometers into miles, you would multiply 70 times 0.6 and you get 42. So if that makes more sense to you, 70 kilometers per second is also 42 miles per second. And again, that's still a lot of distance in a very short amount of time. So if you wanted to convert 70 kilometers an hour into 70 kilometers per second into miles per hour, now you're looking at the totality of how far you're traveling, not in a second, but rather in an hour. So 70 kilometers per second, which is really, really fast, converts to about 156,000 miles per hour. And again, it looks like maybe it doesn't make sense, but when you really think about it, it sort of does. Now, again, this is a relatively big number, so we're going to convert this into scientific notation. And remember, here's our decimal point. So 1, 2, 3, 4, 5. This equals 1.57. We'll round this up because there's a 5 there and there's a 6. So 1.57 times 10 to the 5 miles per hour. And again, what this is telling us is 1.57 times 1, and then we have our decimal point here. We go 1, 2, 3, 4, 5. So basically that 5 means we have 5 zeros. 1, 2, 3, 4, 5. So 1.57 times 10 to the 5th equals 1.57 times 100,000, or 157,000. So we basically said the same thing. You'll notice we have these other significant figures here, these other digits we've sort of negated in our calculation here, and we'll talk about significant figures later on. But for our purposes, rounding up to significant figures of 1.57 times 10 to the 5 makes a little bit more sense. And again, you'll see why in the future when we start to deal with very, very large numbers, or on the flip side, very, very small numbers. Okay, that's it. That is simple unit conversion. If you use a grid, you can convert anything, big or small, units you don't know of that you never heard of. As long as you have the unit conversion factor, you put it into a grid system, you'll be good to go and you'll be able to convert it out. My advice for you is to just practice this stuff. There's some study guide questions that have unit conversion examples. Just do them, go through them, and then just have some fun, come up with numbers on your own and convert those numbers into other units, and see what happens. Now, again, we all know what unit conversions are. You've done it before, if nothing else in your head. I mean, if you watch football, you know that a yard is tantamount to about 3 feet, right? And you know that a foot is the same thing as 12 inches. You also know that a meter is 100 centimeters. I mean, these are all just unit conversion factors that you're very familiar with. So this really shouldn't be anything new to you. It's just a matter of putting pen to paper and actually solving some of these problems. Okay, that's it. If you have any questions or concerns, please let me know. And with that said, we'll catch you next time.